for our last little example on our notes, it says the vertices of triangle JKL are -2, 4, 4, 4, and 1, -2. And they've already graphed that for us on the graph here to the right. It wants to find us the coordinates of the orthocenter of that triangle. So the first thing we have to make sure we understand is that term and how it is formed. The orthocenter is basically the point of concurrency for altitudes. So basically this lets me know what I'm dealing with. I'm going to have to construct some altitudes on this graph and find where they intersect, because the point of concurrency is the point where they intersect, in order to find that coordinate. So we can start with, let's start with the vertex J. And we're going to go, we need to be in altitude, you have to be perpendicular to the side, going from one vertex to the opposite side, or the side to the opposite vertex, and it has to be perpendicular. So if I start with J, and I know that the opposite side to J is KL, I need to find the slope of KL and then look at the perpendicular slope. So I can find the slope of KL just by kind of doing my rise over run, and it looks like we go up 6 to the right 2. So the slope of KL would be 6 over, no, to the right 3, 6 over 3, which is 2. So I'm not going to use that slope. I'm going to use its perpendicular slope, which is a -1/2. So I start at that vertex J, and now, I probably should do this in a different color, but I start at J, and now I'm going to use my perpendicular slope. So that means I'm going to go down 1 to the right 2, down 1 to the right 2, down 1 to the right 2, and I'm going to draw a line through those points. Let's see if I can get this right. And that line is the altitude because it goes to the vertice and it's perpendicular to that side. Now, if I look at that line and come up with the equation of that line, I can see that this line goes across the y-axis as a y-intercept at 3. So usually I would do point slope form for this equation, but I can work a little bit smarter and not overwork and just see that the equation for the altitude, let's give this a point here. Let's say J x. That equation would be y equals a -1/2 x plus 3. Right? So that's the equation for that altitude. Well, I want a point of concurrency for altitudes. I need more than one altitude. So for me, I would just go ahead and start at L and try to, I could have this horizontal line, and if hopefully we remember our OI vux, okay, so if it's horizontal, it has a 0 slope, and it's going to be y equals the number, which is your y coordinate. So perpendicular to the horizontal is going to be vertical. So it will have a vertical line, V for vertical, undefined slope, x equals the number, which is the x coordinate. So I could just draw my vertical line from L all the way straight up and have that altitude to the side JK. And since this line is vertical, since I'm dealing with the vertical line, it's going to be x equals the number. The equation for our vertical line here, and I probably should put another point. Let's make that z. So for LZ, the equation is a vertical, so it's x equal, and it's the point where it crosses the x-axis, which is at 1. So x equals 1. Now, the orthocenter is the point of concurrency for all 3 altitudes. Now, since I already see that the two altitudes are intersecting as such, I could stop right here because I know the other altitude is going to have to intersect at that point as well. And because I have a vertical line and I see that it's x equals 1, I now can take that x equals 1 and plug it into my other equation and solve for y to find that point of to find the coordinate of that orthocenter. Because right here, where they intersect, that's where the orthocenter is located. Or you can kind of guesstimate on the graph. We kind of see that the x is 1, so the y coordinate would have to be, it looks like 2.5. So if I plug it in, I can check to make sure. So when I plug it in, we'll have y equals negative 1/2 times 1 plus 3. So basically, this is just really the negative 1/2 plus 3, which will leave me what I saw, 2.5, 2.5. So I know the orthocenter is the point of intersection for the altitudes. I love the altitudes. Therefore, I can see that that point of intersection for those two lines, the vertical line and the line KL, or no, sorry, JX, was at 1 and 2.5. And that is my answer. So you will see altitudes and a possible orthocenter on your test. I hope that clarifies your steps and gives you some better reasoning. And definitely do the practice, the daily work, in class practice, the pre-AP special segment packet that we got in class to help practice and be proficient with using special segments on the coordinate plane. All right, that's it.